in the examination. We don't want an exact answer of it is 40,000 meter cube per day or 37.5 meter thousand meter cube per day. We are not interested in that. Use this as a scale, and the moment I say Ongol, you should be in a position to write it as around 50,000 meter cube per day. Ongol, Kakinada, more or less population is same. Same is the case if I ask you what is the water demand of Kakinada, Rajahmundry city, you should be in a position to write it. If I ask you what is the population, what is the water demand of Amaravati city, you should immediately know for Kakinada it is 50,000 meter cube per day, which comes to 50,000 KLD or 50 MLD. All these units should be dancing on your tongue. So the moment I say Amaravati Kakinada population is Kakinada area is 25 square kilometer. Amaravati it is 250 square kilometer. So roughly 10 times is the size of the population. So it will not be exactly like 37 lakhs, but around 25 lakhs. So roughly you should know that into 10. That is, it comes to about 500 MLD. Like that, you should be in a position to tell. We are not interested in the exact answer, but you should tell a quantitative expression and a reasonable value you should know. All your questions will be like this only in the examination. And today you all have a glorious future. Today you see 18,000 posts were advertised by Indian Railways. Indian Railways has advertised 18,000 posts for you. 18,000. Any degree is the qualification required for assistant station master post. The starting salary comes to around 50,000 rupees per month. You all have a glorious future. For the posts of attenders and security guards, engineering students are applying. But such type of simple questions, if you can answer, then only, if you can apply your mind, then only you have a future. Next. So these figures should always be there in your mind as scales, based on which you should be in a position to guess other things. Once again, these are all very, very important. That is why, even though this is the fourth class, I am once again showing all these things. Pictures are very catchy. Picture gets imprinted in the mind, subconscious mind. So I want that all these design parameters should be there imprinted in your mind. A open well yields a domestic well, a shallow well in our house yields about 100 to 200 meter cube per day of water. Whereas a maximum deep or tube well, which runs into 2, 3, or 4 strata, that because it takes water from so many strata, the yield is very high. It comes to around 5,000 meter cube per day. In places like East Godavari, West Godavari, which are characterized by an extensive network of irrigation canals and streams, the flow can be as high as 20,000 meter cube per day, 4 times the uh, size of this 5,000. 5,000 itself is a very high value. In these areas, it is almost like 20,000 meter cube per day. So, because there is so much of water, that is why they are very prosperous. The if flow is more than 10 meter cube per second, we call it as a river. The river flow in Godavari is 75,000 meter cube per second. They all should be there in your mind. Suppose I ask you what is the flow of a river Amazon, you should be in a position to guess it as 150,000 meter cube per day. It may be wrong, but it is reasonably correct. You should know that it is a very huge river, so much bigger than River Godavari. So you should know that it is around 150,000 meter cube per day or 200,000 meter cube per day, 125,000 meter cube per day. Anything you write, it is okay. But that sorry, 150,000 meter cube per second, because for Godavari it is 75,000 meter cube per second. Don't look here and there. Be serious. Today, the best, an important point you all should know about quality of water is that groundwater quality is always good. It is 100% free from bacteria. It is 100% free from turbidity, that is murkiness, that is resistance to passage of light. That means the water is very clear. River water or stream water, which is known as surface waters, they are all muddy. That means they have a lot of turbidity in that. They have suspended solids in that. Because of this, they are consumer acceptance will be very, very less. Seawater, for example, seawater remains still for such a very long time. Don't talk about water on the shore. If you go deep into the sea, the entire thing is like a huge tank where water is stored for several millennia. Millennium means 10, 1000 years. So, seawater never contains turbidity. Seawater has zero turbidity. Seawater has zero suspended solids. Seawater has only dissolved solids. Chloride, etc., they all will be in dissolved state. So the compensation of both these things, the best qualities of both these things are, if they are seen, the sweetness of the river water and the quality of groundwater. That is, it is free from pathogens, disease causing bacteria, it is free from turbidity. Because of these, both the good qualities of these waters, infiltration galleries have clicked like anything. They are the best choices now. They are always laid parallel to the riverbed. I am repeating them because they are very important. Let us just safe water or wholesome water or potable water, which is drinking water. As per the, they prevent as many as 20 well-known diseases. Why I have kept give prominence to the term diarrhea? Because it is the number one child-killing disease in the world. In the entire world, same is the case with typhoid. Same is the case with hepatitis. They are also very dangerous. And child means of age less than 5 years. And every day throughout the world, mortality word has come from the Sanskrit word mrit. Hey, Mister, what are you doing? Every day, 22,000 children are dying globally. That means if you take all the 224 countries of the world, plus or minus a few, every day 22,000 children are dying, and the number one reason for the killing of these children is lack of potable water to them. And in India, proportionately the population is very less. Proportionately population is 130 crores. So for 720 crores, if the child diseases is 22,000, if you say for the 130 crore Indian population, the number comes to roughly around 3600 or so per day. Whereas in India the number is 7200 per day, only because India is still a developing country. It is still so many people are dying only because of people like you who do not have any social responsibility. For you, study is something like a fun. We are not serious about what we are doing. We never put a question to ourselves, what for we are here? What is our primary duty? Those things we are not serious. We are not concerned about it. That is the only reason. Only because the engineers are out of track. The country is going into doldrums. Is in a very shabby position today, the country. The majority credit goes to especially the civil engineering students. Civility means polite behavior. Civilization engineering, this branch has come. Civilizations have prospered only because earlier times people, even though they were not engineers, they were behaving with a lot of sense of civilization. Today, even the best of civil engineering students also have completely forgotten their responsibility. As a result, this is the case today. And if you continue in the same limits, same state of affairs, just imagine how your children, grandchildren, next generations, how they would suffer because of your callous attitude. Next, please. These are all very important aspects. So that is why repeatedly I am showing you. This is for a very prestigious water supply project for Tirumala. It is mostly visitors paradise. 4.5 mld is the design flow. 55 kg per centimeter square is the design pressure. 1 kg per centimeter square corresponds to 10-meter head. To be very precise, 1.03 kg per centimeter square is standard atmospheric pressure, or 1 bar, which corresponds to 10.3 meter of water. So if you remember this solidly, then the moment I say 55 kg per centimeter square, immediately your mind should catch that it is 550 meter head. In simple terms, the head is 550 meter, means the water should be, the pump should be in a position to lift water to a height of half kilometer, which is actually Tirumala. In addition to that, it has to overcome the losses in the pipeline also, which is HF is equal to FLV square by 2GD. Once again, we are seeing that the modern day water supply, as a civil engineer, it is your responsibility to see that you are in a position to supply water even to the remote part of the country, remote part of the state, which are completely dry. If you can supply even a few liter of water to that, then this is sufficient. And today the term green is used for saying energy efficient. So in a remote area, using solar panels where there is no electricity connection at all, no electricity connection, just carry some solar panels, lift some, convert the solar energy into electrical energy, and see that it is the water is lifted, and you are getting a few liters of water in the whole day. This is sufficient. For example, this particular vessel has a volume of maximum 500 liters. So in a single day, if you get 500 liters also, that is more than sufficient in some cases. Next, please. We have already seen if water is contaminated, it leads to several diseases. And we're all aware that in Japan, the industries, they disposed of mercury waste into the ocean, thinking that mercury's specific gravity is 13.6, water is specific gravity 1, water has specific gravity 1.03 for seawater. So when I dump mercury, naturally it will sink to the bottom, and because it is inert, because it is inorganic, it will not cause any effect. That was the simple scientific phenomena, we know it. So based on that, they dump. But what happens is the ecosystems are so sensitive that one particular type of organism converted the inorganic mercury into dissolvable mercury. So it converted its form. For example, chlorine is one form of Cl. Chloride is another form of Cl. NO is one form of nitrogen oxide. NO2 is another form. NO3 is another form. N2O5 is another form. Like that, there are nearly 7 or 8 types of nitrogen oxide. The same way, mercury also can be available in different forms. So these particular bacteria, it converted that inorganic inert mercury into a solvable form. As a result, it was converted into methyl mercury. The moment it is converted to methyl mercury by this particular type of bacteria, it got dissolved in seawater. And fish which they drink this mercury, they have high potentials of withstanding mercury poisoning. So nothing happened to them. Generally, if a fish die, immediately fish are indicators of pollution. The moment a fish dies, we can understand that some problem is there with water. But here, the fish could survive because God has given it a particular type of system that they can withstand very high levels of mercury. So they were happy. So the people who consumed these fish, they started dying. So this particular type of disease is known as Minamata disease, because Minamata is a bay in Bengal. It is world over, all the countries. This is a very branded disease. So it is caused by mercury poisoning. So in the labs, for example, we all use mercury. Fluid mechanics lab, we use mercury. Or in the environmental engineering lab, we use mercury. All research labs use mercury. If this mercury, if it is wasted, and if we simply dispose of even 0.001 mg per liter of mercury, it can cause a lot of problems, health problems. So that is why, even though it is very, very small, these are all highly toxic. So the disposal should be, we should take care of the disposal methods. Iodine causes, iodine is the very big natural disease. So if iodine deficiency is there, the diseases like cretinium and IDDs are caused. Iodine deficiency disorders. Next, please. Let us very quickly go through one of the beautiful works. In fact, the professor of civil engineering dealing with the subject of water supply engineering in one of the colleges in this, that is Aditya Engineering College, she has actually done this type of beautiful work as a part of her MTech in environmental engineering. Let us very briefly go through this. Victoria Waterworks Kakinada, which was established 110 years before in Kakinada, caters to the needs of 50,000 meter cube per day. What is the total annual expenditure for operation and maintenance? O&M means operation and maintenance. It is 8.75 crore per year. So in the form of salaries they pay, mainly in the form of salaries, and for the power cost, electricity charges, and the cost of chemicals, etc. So what is the cost per, say, 8.75 crore per year? And per year, how much water is treated? 50,000 meter cube into 365. So you divide this by this. How much you will get? Rupees 5.32 per meter cube of water treated. 1 meter cube is 1000 liters. So what is the treatment cost per liter of the uh, treatment? It is only zero point 0.5 paisa. So we have to understand these are all very interesting things. So what is the cost of mineral water in the market? It is not rupees 0.5 per liter. It is rupees 5 per liter. That is zero point 0.5 paisa. This is 5 rupees per liter. We are purchasing for 5 rupees now. In JNTU Kakinada campus, if you see, it is typically you will get normal plants, you will get it for 5 rupees per liter. If it is Kinley, it is 20 liters. If it is Koi, it is 50 rupees per liter, like that. So why the cost is so less? It is a very important phenomena. Whenever you are treating water in a huge quantity, the cost of the water, it comes down drastically. This is a very important economical aspect. Treatment cost per liter decreases with quantity. Similarly, large industry produces less pollution per unit product. Out of this 8.75 crore annual expenditure, the chemicals cost about 1.2 crore per year. Out of this 1.2 crore chemical also, alum alone costs 1.02 crore. So main cost is 1 crore. Every year you are spending 1 crore only on alum. We have mainly two places from where alum comes. Alum, each ton costs about 15,000 rupees in the market. That means 1 kg costs 15 rupees. We get alum from either Gujarat or West Bengal generally. So if we use a dosage of 50 mg per liter or 60 mg per liter, these are all run by people who do not have any sort of education, and they are not educated also, because their boss, that is who is an environmental engineer, if you are aware of it, how to decrease it, because you can educate him. You should first know it. So people simply dump alums without any, not in a scientific manner. If you can do it in a scientific way, in a beautiful way, then the cost can be reduced drastically. Just because if you can understand the process of treatment by alum properly, only because of you, your city can save easily 30 to 40 lakhs of rupees per year. Next. Generally, the term green is used for several cases. Green has those meanings which are in yellow color. They are in the negative side. So let us not bother. The main meanings of the term green is environmentalist. He is a green, means he is an environmentalist. Environmentally friendly, energy efficient, sustainable. Sustainable means he always thinks for the next generations. He is not very selfish. He is not selfish. He thinks about the next generation point of view. He thinks full of life and vigor. That is the meaning of the term green. Green word has come from the Sanskrit word jiva. Jiva means life. Fresh, green concrete. When do you call a concrete as green concrete? If fresh, latest, just now you have made the concrete. It is very fresh. We call it as green concrete. New, recent. These are all the meanings of the term green. Next, next sir. Now last time we have just shown this and then it was cut. This is a very important point, your gate examination point of view, and throughout your life it is very important, and that is 1 ppm corresponds to 1 mg per liter. 1 mg per liter, 1 ppm means 1 part of the substance per million parts of water. Then we call it as ppm. That means if you take chloride or fluoride or iron or manganese or aluminum or anything, let us say 1 milligram fluoride is present in 1 million milligram of water. 1 million means 10 to the power of 6 is equal to 1 mg fluoride per 10 to the power of 6 mg means 10 cube gram. 10 cube gram, 1000 gram means 1 kg. 1 kg means 1 liter. 1 kg water is 1 liter. So it corresponds to 1 liter of water. So 1 ppm is equal to 1 mg per liter. This is a very, very important aspect you should realize throughout. Unless and otherwise mentioned, we should always express it as mg per liter only. And small m only you should write. Small g only you should write. Small l only you should write. Any other thing if you write, you are wrong. For example, there is no unit like gm for gram. For gram, it is small g, that's all. You cannot write capital L. Similarly, per liter, capital L, if you write it, is wrong. 100% wrong. Another important aspect, if the concentration is very high, we don't express in mg per liter or ppm. We express it as percentage. For 1% corresponds to, when do you say 1%? 1 milligram of a substance is present in 100 milligrams of water. So let us say calcium or chloride or sulfate or aluminum. 1 milligram is present in 100 milligram of water. Multiply numerator and denominator with 10,000. Why you are multiplying with 10,000 suddenly? Because you know that 10 to the power of 6 milligram of water corresponds to 1 liter. So you know what you have to do. That is why you are multiplying with 10,000. So 10,000 milligram calcium per 10,000 into the 100 comes to 10 to the power of 6. 10 to the power of 6 milligram of water. 10 to the power of 6 milligram of water is once again 10 cube gram, that is 1000 gram, that is 1 kg, that is 1 liter. And 10,000 mg is 10,000 mg only. So 1% corresponds to 10,000 milligram per liter of water. So this is a very important thing. And if you understand this and remember this, you can solve one problem in the gate examination. Always one problem definitely is asked corresponding to this. They may not directly ask you, but the problem involves, they say that the brine water, the brine has a chloride content of 3.5%. And without knowing that, you cannot proceed further. Godavari water has a TDS of about 300 mg per liter. TDS means total dissolved solids, which is the sum of chloride plus sulfate plus calcium plus iron plus aluminum plus zinc plus chromium, all these put together. All these elements in water are in dissolved state only. They are not in a state of suspension or settleable state. They are not in settleable state. For example, our blood is red in color only because it contains iron. Iron is available in which form in the blood? Is it in a settleable form? No. If it is in a settleable form, then all the iron will come down and settle in the foot by evening. That is not the case. It is dissolved. Dissolved means dissolved only. Okay. So seawater has a TDS of 3.5%. So what is the concentration in ppm? 35,000 mg per liter. So how many ppm? 1 mg per liter is equal to 1 ppm. So 35,000 ppm. Next please. This is a gate question in the year 2013. Once again, I'm telling you, one gate question, similar question, if you get it tomorrow, take it for granted in 0.63 marks, you will lose admission in IIT. Such a narrow, so much of competition is there. And for getting all the jobs in all government sectors like steel or ONGC or NTPC, in all these government sectors also, public sectors also, today you must be qualified in gate examination. So, and in some of the cases, for some particular types, qualifying mark is very less. Out of 100, if you get 12 marks also, you may be qualified. So 1 mark, if you are getting just like that, it is a very big thing. So let me spend some time on this question, even though it is not related to your subject. Because a similar type of question can be there. This is very important aspect. The question is, 8 gram of SO2 occupies dash liter. That is the simple question. ABCDs will be there, of course. Now to answer this, 1 mg per liter is not equal to 1 ppm in case of gases. That's what you have to understand. Only for water it is. Why? Because 10 to the power of 6 milligram corresponds to 1 liter in case of water. Is it so for gases? For gases, it is not so. For water, 1 liter of water weighs 1 kg, occupies the same volume of 22.4 liters at 0 degrees centigrade. That means what is molecular weight of what is molecular weight of SO2? 32 plus 32, 64. What is molecular weight of CO2? 12 plus 32, 44. What is molecular weight of CO? 12 plus 16, 28. That means 28 grams of CO occupies 22.4 liters. 44 grams of CO2 also occupies the same volume, 22.4 liters. 64 grams of sulfur dioxide also occupies the same volume, 22.4 liters. You name any gas, if its molecular weight is m grams of that gas occupies the same volume of 22.4 liters at 0 degrees centigrade. At 27 degrees centigrade, it is slightly more. As temperature increases, it occupies more space. So the answer is 24.5 liters. That is the difference business only. So 28 gram of CO occupies 22.4 liters. 44 gram of CO2 also occupies the same volume. 46 gram of NO2 also occupies the same volume, 22.4 liters. 64 gram of SO2 occupies 22.4 liters. So 8 gram of SO2 occupies 22.4 into 8 by 64 is equal to 2.8. It's a very, very important question. And next please. Now let us get back to this question. Why I always concentrate on units, etc., is that if you do not know this, then you cannot solve any problem in future. You cannot solve any problem in future, because ultimately the question he will ask in acres, or he will give data in acres, but you have to give the answer in diameter. You have to give it in pipe only, in meter only. So unless you are very thorough about units, you cannot do anything. 1 square kilometer is 1 hectometer by 1 hectometer. 10 hectometers by 10 hectometers. That is 1 hectare. So 1 square kilometer is 10 hectometer by 10 hectometer. So it is 100 hectares. And 1 square kilometer is equal to 256 acres. 1 acre is roughly, it is not exactly 4,000 meter square. That means 40 meter length, 40 meter width, and 100 meter length. 100 meter, you all know it. That is why every student, if he participates in running at least once in a year or twice in a year, 100-meter running race, he can easily imagine what is 100 meters. One hectare is 100 meter by 100 meters equal to 2.56 acres. Kakinada 25 square kilometer. Amaravati 250 square kilometer. Chennai 400 square kilometer. So if somebody asks you what is the area of Madras, you should be what is the area of Mumbai or Delhi or Calcutta. You need not know it. I also do not know it. But you can guess it very easily, because Madras is a very big city. More or less the area must be same. Yes or no? That is how you should think. Never say no. You tell some approximate value. AP area is 150,000 square kilometer. Andhra Pradesh is like a long stretch. We all know that from Srikakulam to Tada, where we have the national highway, or the coast length of Andhra Pradesh is 1,000 kilometer. The national highway, the golden quadrilateral in Andhra Pradesh is 1,000 kilometer. So what is the length of Andhra Pradesh? 1,000 kilometer. What is the width of Andhra Pradesh? Roughly 150 kilometer. So that is why area is 150,000 square kilometer. What is the area of East Godavari district? Somebody asks you. You need not know it. This is not the exact value also. You know that there are 13 districts. 50,000 divided by 13. So it comes to roughly 11,000 kilometers. You should think like that. 1 meter cube is 1000 liters. 1000 means kilo. If you want 8,000 rupees from your father, what do you ask? Dad, please send 8k. 8k means it is not 8 kilo. 8 kilo only. Kilo means 1000. Kilo means 1000. So if you ask for 8k, your dad will send 8,000 rupees. Similarly here, 1000 is kilo. So instead of saying 1000 liter, we say 1 kiloliter. 1 liter corresponds to 10 centimeter by 10 centimeter by 10 centimeter, which is equal to 1 kg force for water. We're all talking about water. Once again, 1 TMC is equal to 1000 million cubic foot. So if today, even a political leader, who is a fifth class failed political leader also is talking in terms of TMC. As civil engineers, how much of clarity you should have about TMC? Very, very important parameter in civil engineering. Very important. This is important not only in water supply engineering, water resources engineering, future hydraulics, irrigation engineering. In all subjects, if you do not have the clarity of the subject of TMC, you are most unfit civil engineer. So 1000 million cubic foot, 1000 into 10 to the power of 6 into 0.305 meter is equal to 1 foot cube. It corresponds to 28 into 10 to the power of 6 meter cube. So this figure of 28 into 10 to the power of 6 meter cube should always be there in your mind, on the tongue, the fingertips. This is TMC is unit of volume, but 1 TMC water is sufficient to irrigate 10,000 acres of desert land. That means if you can supply 1 TMC of water, then 10,000 acres can become very fertile and rich. Just imagine many farmers with 2 acres. If you can supply water to them, 2 acres, then throughout his life he will be grateful to you. Whereas using your technology, using your brain, if you can supply water to 10,000 acres, if you can supply 1 TMC water, what results you can bring? So 10,000 acres correspond to 40 square kilometer. This conversion you should be very, very clear. Only because of practice you will get it. Bhagavad Gita says, Abhyasena tu kaunteya. Abhyasam means practice. Let us solve this beautiful problem. 2 days of Godavari flow into the sea was left out about 1 year before when there were floods. There was excess water. It was all let into the Bay of Bengal, wasted. Suppose, as a civil engineer, if you conserve that water, if you save that water, if you store that water in a reservoir, what happens? 75,000 meter cube per second into how many seconds the water was let out? 2 days means how many seconds? 2 into 24 hours into 1 hour is 3600 seconds. Like that, when this is in second, that must be in second. Then only that clearly you will be doing very easily. It corresponds to so many meter cube. And 28 into 10 to the power of 6 meter cube is sufficient for 10,000 acres. So how many acre can be irrigated, or how many square kilometer can be irrigated? What is the answer? How many TMC you have got? First tell me how many TMC. You know meter cube? You know so many meter cube. This answer you know. Meter cube. 28 into 10 to the power of 6 meter cube is 1 TMC. So how many TMC water was released? Huh? 465. Okay, not a problem. 460. Roughly 460 TMC water is wasted. Why we have wasted into the sea? Because we have sufficient amount of water. What happens if you supply that water to Nalgonda? or Chhattisgarh or Anantapur or Kadapa. Kadapa is the district where population is decreasing because non-availability of water. So supply this water to Kadapa. What happens? All these areas also will flourish. That is what you have to think as a civil engineer. We are all global engineers. Don't think that this water belongs to Kakinada or East Godavari or West Godavari only. It is for the humanity, because engineering is application of mathematics and science for development of technology for the benefit of mankind. So you should always think like that. Have you understood now? What is the area of Prakasham district? Roughly 10,000 square kilometer. So how much area it can say? How many TMC you got? 460 TMC. Just imagine. 1 TMC is sufficient for. So 460 TMC is sufficient for how many square kilometer? How many square kilometer? 80,000 square kilometer. And what is the area of Andhra Pradesh? You have seen 130, 150,000 square kilometer. So how many districts they can be satisfied? So many districts. That is how you have to preserve water. Next please. Now, most of the land area is covered by ice, and 75% of the fresh water is available in ice caps and glaciers at Arctic and Antarctic zones only. What you are seeing actually is the Siberia, whose area is 2.5 times that of India, and population is very less. There are so many underground townships. Now there is an idea that why not bring all this ice to hot areas like our country and then convert it to drinking water, because ice contains only pure water. Pure water only becomes ice. Take it for granted. That is one beautiful phenomena, natural phenomena. It is called paradox. Next please. So forget about the right side clipping when the Titanic sunk. This is the newspaper clipping of the day. But forget about that. The whole sea sea contains all sorts of salts. You name any salt in the world, you will find it in the sea. Because a river, when it flows through mountains, forests, so many things, it brings all the minerals and dumps into the sea. So sea contains all minerals. And when water evaporates, only pure H2O evaporates, leaving behind the salts in the sea. So see, continuously salts get accumulated. But but so all these salts, they form in the they are all in the form of all salts are ejected. Only pure H2O you will find it as ice. Now the current phenomenon is, because water shortage is there, pure water shortage is there. They want to tow and drag all these mountains to the places where the melted water can be used for drinking water. Let us see what happens. Next, please. Next. This is a iceberg. Ice has specific gravity of 0.99. That means if 100 centimeter by 100 centimeter by 100 centimeter ice block is thrown into water, 99% of it will submerge in water. 1 centimeter only will be there above water, because its specific gravity is 0.99. Just like if a 0.65 specific gravity wooden piece is thrown into water of size 1 meter by 1 meter by 1 meter, 0.65 meter will be submerged in water. Only 0.35 meter of it will be above water. The same way ice is 0.99 specific gravity. Okay, next. So if you are seeing this particular iceberg, it is not in cubical size. Generally on the top it is something like a hill. It also is like a hill. So as a result, generally the general criteria is, if you are seeing about 5 meters on the top piece, huge mass is there inside only. 99% of it you are seeing 1 meter or 1 unit you are seeing on the top. 99 units are seen below the sea, are there below the sea. They are not seen. That is why in psychology every human being is compared with an iceberg. We exhibit only 1% of what we are actually or factually. 99% of our capabilities we do not exhibit at all. They are not seen to the world, seen by the world. Now calculate how much water is available in this particular iceberg. It is world's largest iceberg. The previous one which you have seen is the world's largest iceberg. It is of size 300-kilometer length, 100-kilometer width, and 50-meter height. What is the pure water? Pure water. It is just like distilled water. It is more than distilled water. Water obtained by melting ice is equal to, it is 100% distilled water. Pure water. It is not like river water also. River water also is a very fresh water. It contains very less. But absolute zero salts. How many meter cube? 1500,000 into 10 to the power of 6 meter cube. Now, how many TMC? 53,000 TMC. So one iceberg, and what is the weight of, in fluid mechanics you have studied? What is the weight of any floating substance? Zero. Because how you have calculated in fluid mechanics? The weight will be acting in downward direction. Buoyancy, bio means upwards. The upward force is always equal to the force. That means what is the net force acting on a floating body? Zero. Net weight of any floating object is zero. The weight acts downward direction, but the water always tries to lift with a lot of force. That force is always equal to the weight of the gravity force, gravity weight of the object. So net weight is zero. That is why if there is a wooden log in a water, you can easily lift it. When you put a bucket in water, you will understand this. As long as it is there in water, you will not feel any weight. The moment it comes out of water, suddenly you will find it is very heavy. Any floating object has no weight. So this also has no weight. Only thing is you should use some force to drag it in water. Just like it is just like dragging a fish in water. Does it require any force to drag a fish in water? Maybe it requires, but very less. Same is the case. Now the idea is, why not we drag all this and convert it to drinking water? Next please. This is a very, very beautiful technique, very interesting technique. You all can do a small exercise, experiment. And the experiment is, when you go to beach, bring some water, salt water, sea water, and keep it in the refrigerator compartment, freezer compartment of the refrigerator. You know what happens? Pure H2O only becomes ice, and the salts are left behind. So how to convert seawater to drinking water? The simple thing is, keep it in a freezer compartment. The water, pure H2O only becomes ice. Convert it, you bring it out, you keep it in a vessel, and then it is melted because of the higher temperature. When it is melted, you will get normal water. But the efficiency, it contains some salts, because what happens is, when you take out the ice block, the salts also will be there left behind. So they will be adhering to that ice cube. So when you bring, some salts may be there. That is why the best thing is, ice immediately it should be washed. If it is washed, what happens? All the salts attached to that, they will wash out. And then if you allow it to melt, you will get perfect pure water. So freezing is a very good technique to convert seawater into drinking water, pure water, or DM water it is called, demineralized water. So it is an advanced method of water treatment. So what to do that? Only pure water becomes ice, leaving behind the salts in water. Example, seawater kept in freezer of refrigerator, tubbing of ice best to solve water scarcity problem. It's a very, very important point you all have in the syllabus. So only thing is, if temperature is very, very less, for example, sometimes in Siberia, temperature is minus 40 degrees centigrade. In refrigerators, we can maintain very, very less temperatures also. Many fish, aqua ponds, fish ponds, where fish are preserved for a long time, they are sometimes preserved at minus 20 degrees centigrade like that. So what happens if the temperature is very less? If it is less than minus 8 degrees centigrade, Na2SO4 crystals are formed. And if the temperature is less than minus 23 degrees centigrade, NaCl crystals are formed. So what is the condition for freezing? What happens if these crystals are formed? Ice also is in the form of crystals. NaCl and Na2SO4 also are in the form of crystals. So you cannot identify which one is ice and which one is salt. So to separate water crystals only, it is ice crystals only, you should see that other substances their crystals are not formed. That means the temperature must be in the range of 0 to minus 8 degrees centigrade only. That is the only point. Why? This is the reason. Am I clear? So this is also a very important question, that whenever seawater is to be converted to drinking water, the temperature in the freezer should be maintained at 0 to minus 8 degrees centigrade only. Next please. Another very important aspect, an age old, it is believed that Julius Caesar, a great warrior, he conquered the world, and whenever he was on a ship, we needed fresh water to drink. So how to convert seawater to drinking water? That is a simple phenomenon he always used, and that is like this. Even today the same method is used. Just see, you all must have seen in the Discovery Channel, when people on the coast, they do not get any water. Do you know what they do? You must have seen in the Discovery Channel. Suppose this is seawater. On the top of the seawater, they keep about some 1 meter size. 1 meter means some size plastic sheet. They cover it. What happens if during the daytime the water evaporates? As the water evaporates, the water vapor is attached to the inner side of this plastic cloth that gradually drips. When water evaporates, what evaporates? Only pure H2O evaporates. When ice becomes, only pure H2O becomes ice. When water evaporates, pure H2O only evaporates. Salts, they do not evaporate. For example, if you play any game, you wear a dark color pant, play a game for 3 hours or 4 hours, and just like that you leave it. What happens? The salt, the sweat is full of salt only. The sweat, it gets evaporated. Pure H2O gets evaporated. When pure H2O gets evaporated, what happens to the wet cloth? The salts are left behind on the cloth. So you will find white color patches. They are salt patches. Am I clear? So exactly the same way, uh, here also, if there is a cover like this is a plastic cover. I have shown like this, but it is any ordinary plastic cover, plastic sheet, polythene sheet. If you cover like that, if you keep it like that for a few hours, 5 to 6 hours, what happens? Pure H2O gets evaporated, and they will be attached to that. So they all will gradually drip into the sides. So if you can collect on the side, whatever water that you collect, it becomes fresh water. So this method is known as solar still or distillation. Please write the word distillation. This is distilled water actually. This is distilled water. Distilled water is nothing but this only. That is why all the rain that comes is distilled water only. Rainwater is nothing but distilled water only. Except the first few minutes of water, it collects some salts, or it may collect CO2, and H2O plus CO2 gives H2CO3, mild carbonic acid. As a result, the pH value may be less, it may contain some thing. But how we get rainwater? Seawater gets evaporated. When it gets evaporated, what is evaporated? Is it salt is evaporated? No. Salts are left behind. Only pure H2O gets evaporated. So the pure H2O is falling here, is condensing and then falling. So whatever rain we get, you can do this as a small experiment in your lab, which is there as a part of your syllabus also. There is one conductivity meter, collect rainwater sample and dip that water in the electrode. Today, thanks to technology, everything is digitalized. The moment you insert an electrode, you will get the value. What is the salinity? How many salts are there? Okay. So brine means concentrated salt solution or seawater. So if it is evaporated, it happens. So, but only problem with this is the amount of water that we get will be very, very less. How much water we get? 3 liters of water in one day for 1 meter square area of the evaporator plate. But if there is a family living on a remote area, and if you cover somehow 5 meter square area, if the surface of the sea is covered at a distance, if you can maintain, suppose this is sea, on the top, if you can maintain a 5 meter area plate like this, and if you can collect the water, you will get 5 into 3. That is 15 liters of water you get, which is sufficient for drinking and cooking. Yes or no? Then for taking bath and for other purposes, maybe you can use this seawater. This is also a very, very important point, which is there in the syllabus for every one of you. They are interesting or not? Very interesting, very simple, and they're all natural processes. What is the cost involved in this? How much cost? Almost nothing. Is there any pump here? Is there any complicated device here? No. But what is the disadvantage of this system? The amount of water that we get output is very, very less. Next, please. Now, oh, okay. Now this is a very, 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 very important topic throughout life. You must remember, and in the examination, you need not even see the question paper. You can write down those points. So important they are, and throughout your life, you will be dealing with them. Indian standards 10,500 1991 gives drinking water standards. For the first time, we are discussing the latest standards which were implemented in the year 2012. You may ask, when it was introduced in 2012, why you did not teach them in 2012 or 2013. Whenever such standards are implemented, it takes a lot of time. They will be put in the website. All people will be asked to discuss those lines. For example, now Amaravati is coming. The master plan of Amaravati is there in the website. Every one of you can go through that. And if you want, you can suggest some things for that in the master plan. You can say that the road should not go like this. If the road is here, it is good. You may suggest that here, if a park is placed, this is good. You may suggest that if wealth from waste concept is used, if tires are used for construction of roads in this particular area, that is better. You can say that as per Vastu, hospital should not be located here, it should be located somewhere else. Whatever you want, you can do it. You should use your knowledge. That is why they keep it in the website now. It is open for discussion. And after all these discussions only, they are finalized. But most of you will keep quiet now, and tomorrow, when everything is implemented, you raise your voice against the government, saying that it has done that mistake, it has done this mistake. Have you raised your voice? What are you do? How you are spending your time? At least go through that. The same way, these standards also are kept in the website for a long time. They are open for discussion. Intellectuals can discuss it. And if you observe 1991 standards and 2012 standards, there will not be any big difference. And most of the standards are same. Now let us get back to this. All these things you have to remember. There is no other way. But remember, don't blindly. It is called rote learning. Rote means learning without understanding. Studying without understanding is called rote method of learning. R-O-T-E, rote. In Hindi, it is called ratna. In Telugu, it is called batti. Batti patad. Batti kodite, baddi kotte. ఏమన్నాడు మురళీకృష్ణ? బట్టి కొడితే వడ్డీ కొట్టే. అంటే if you study without understanding, just like that, if you spend 4 hours or 4 years of the JNTU, then the life will be like that only. Okay. All these things, these are the physical parameters. Color, desirable limit is 5. Maximum permissible limit in the absence of alternate sources is 15. The IS code always gives standards for drinking in 2 columns. One is desirable limit. The other one is, it also is permissible. You can drink it. Nothing happens to you. But only if an alternative source is available. That means it is giving you some sort of warning or it wants you to be a bit cautious. What do you mean by bit cautious? Suppose there is an infant. Infant means less than 6 months or less than 1 year is called infant. Or there is a child of years less than 5 years. They are very sensitive to water. So when it comes to drinking water for them, when if the waters are not as per desirable limits, you don't experiment on them. You purchase mineral water for them. How much water a child drinks? How much water an infant drinks? An infant less than 1 year age children. How much they drink? Do you give water with a mineral water bottle? Etata bottle etata. How much you will give? You will always provide with spoons. Spoon. Spoon means how much? 1 ml. So in the whole day, they consume water maybe in mls or at the most half a liter. Let us say all things put together. If they drink 1 ml, 1 ml goes out also. But whatever it is, that water you use it as bottled water, like a Kinley or Varsha or whatever brand is there. That bottled waters you give them good quality water. Yes or no? Because that quantity is less. That is the meaning of this. But for you, it's okay. Desirable standard there is no rule. Permissible is okay, fine. That is how you have to understand. For order, it should be agreeable. Taste, it should be agreeable. pH should be in the range of 6.5 to 8.5. It is desirable standard. Permissible standards, no relaxation. That means what are the standards? Same, 6.5 to 8.5. Turbidity. Turbidity, earlier there was another instrument used. Prior to that, platinum cobalt scale was used. Later, Jackson turbidity meter was used. Now a new instrument has come that is called nephlometer turbidity units. The name of the instrument itself is nephlometer. But the government has found that this instrument can be standardized. Even though it is a brand, the government felt that nephlometer, the method of measuring turbidity by nephlometer is very standard. So let us form universally that nephlometer is a standard instrument. So whatever nephlometer measures, that turbidity unit, it should be 1 per desirable limit. It should be 5. What is meant by turbidity? Turbidity is the resistance to passage of light. If water is dirty, light cannot pass through that. That means its turbidity is more. So turbidity is resistance to passage of light. And here in this instrument also, the phenomenon is same. There will be a light here, water sample will be kept here, and here the intensity of light will be measured. In cricket matches also we see if the light is less, they measure the intensity of light using an instrument. What is that instrument? It is called lux meter. Lux, lux is the unit of intensity of light. So what is the basic source of thing of measuring the turbidity here? There will be a light source here. Here water sample will be kept in a tube, test tube. Light passes through this water. If water is 100% clear, the intensity of light will be very high. Here there will be a receptor which receives the light. So which measures the intensity of light. If water is turbid, it measures the light intensity as less. So this is a calibrated instrument. Then TDS. TDS is not salinity actually, but in general thing, TDS represents salinity. Salinity means salts. TDS stands for total dissolved solids. What are the total dissolved solids? Clay, sand, silt. They are not dissolved solids. They are settlable solids or suspended solids. Clay does not, silt, it may settle after some time. Sand is a settleable solid, it immediately settles. Silt, it takes time. Clay, it does not settle at all. It will be in a state of suspension. It is always in a state of suspension. Throughout water you will find it. But it is not dissolved in that. It is in a state of suspension. It is called suspended solid. Then solids which are much finer than even fine clay, they are dissolved solids. They are iron. Iron in water is always in dissolved form. Mercury in water is always in dissolved form. Mercury, what happens if it is in suspended form? or settleable form. If you leave water like this, after 1 hour, you should find next day morning you should find mercury on the surface. Is it found like that? Have you any time found iron like that? They do not settle. They are all these salts. They are in dissolved state only. Calcium is in dissolved solid. So TDS is chloride and sulfate. Mainly calcium, magnesium. Mainly only these salts. But iron, mercury, sodium, aluminum, zinc, chromium, boron, all these values put together will be 1 or 2 mg per liter or maximum 5 mg per liter. Whereas chloride in drinking water is almost about 50 mg per liter in river water. In groundwater, it may be around 500 mg per liter in Kakinada. Whereas in sea water, what is the value of chloride? 15,000 mg per liter. Am I clear now? Once again, seawater does not contain any suspended solid. Seawater does not contain any settleable solid. It contains only all salts it contains, but all in dissolved form only. For TDS, this is the limits. Next please. When it comes to pH, you all are aware the pH is minus log H plus. It is minus logarithm of H plus concentration. So, it is the theoretical range of pH is, whenever we say range, you should tell two words, minimum and maximum. What is the theoretical range of pH in water? Theoretical means theoretical 0 to 14. If it is 7, neutral. Lemon juice, nimmakai rasam, has a pH of 2. All the battery acid has a pH of 1. Stomach acid means whatever is there in the stomach, inside acids only are there. Full the stomach contains acids only. So whenever a child vomits, it is very dangerous to the tiles. Tiles are all highly alkaline. They are limestone. So limestone gets spoiled. Marble gets spoiled. Only because whenever a person vomits, whether it is a child or an elderly person, it is 100% acid. In Hindi, it is called Tejab. There is a movie also with Anil Kapoor as hero, Madhuri Dixit as heroine. Then vinegar, soft drinks. Most of you must be thinking that cool drink it is very good. During examinations, you will feel that some problem is there in the stomach. It is due to acidity. It happens. Whenever a person is in tension, the mental problem is there, psychological problem is there. It leads to a lot of acidity. Physically also reactions they take place, chemical reactions they take place. If you are in anger, then lots of acids are produced. So whenever during examination, definitely acidity problems will be there. During that time, what happens? If you drink soft drinks like cool drink, your best friend would always suggest cool drink, cool drink. But what happens if you take cool drink? It is further aggravated. It becomes very serious. What is that you have to do? Will you drink lemon juice? Much more dangerous. Will you drink apple juice? Much more dangerous. Will you drink tomato juice? Much more dangerous. Which you drink wine? More dangerous. Then what is that you will drink? Will you drink battery acid? What is that you will drink? All fruit juices are highly acidic. All cool drinks are highly acidic. And the only thing, fresh milk has a pH of about 6.5. And human blood is a pH of 7.5. You cannot drink blood. Chiranjeevi blood bank, don't go to that. Will you drink blood? Blood is alkaline, but you cannot drink blood. What is that you will drink? The only thing that is available is, will you drink baking soda? Will you eat soft soap? Will you drink seawater? What is that you will drink then? The only naturally occurring alkaline substance in this world is the elixir of life, and that is normal drinking water. The only solutions to all these problems is drink water as much as you can. That is the only thing. Water has one good quality in that one parameter. It is called alkalinity. What is alkalinity? It is the ability of water because of which it can resist a change in pH. If the water, if something is highly alkaline, it will reduce it and make it neutral. If it is something highly acidic, it will bring it to neutral. Whether it is alkaline or acidic also, it will bring it to neutral. That capability water is having because of one property, and that is called alkalinity of water. So the only solution is drink water. Water, water, water. Next please. Can you drink distilled water? Pure water, can you drink? What happens if you drink distilled water every day? Even though it is available freely. Distilled water has no salts in it. Pure water has no salts in it. It has no alkalinity at all. It cannot fight any change in the pH. Its alkalinity is zero. So it is of no use. Can you drink rainwater every day? Every day. What happens if you drink rainwater? You are not Trisha that you can drink rainwater as in the movie of Varsham. Once in a blue moon, once in a while it is okay. But regularly distilled rainwater is nothing but distilled water. If you drink distilled water, then it cannot perform its duties. Water has to perform so many duties. What are the duties water performs? You have studied. It regulates the body temperature. It controls the acids. It throws out the waste materials in the form of feces. All these things are done by water. It cannot perform. If it has to perform its duty, it should have the quality of alkalinity. And distilled water or rainwater has no alkalinity at all. So once in a blue moon you can drink, but on regular basis you should not. Now all this you have to remember. There is no other option. But there is some basic understanding if you have, then you can remember the values very nicely. And we don't expect that you will reproduce the values as it is. I will tell you how to write these values. What is the time now? 3:25. Huh? 3:20. Fine. Now observe this. Observe the last point. Chloride, which all is in red color. What is the third point? Free residual chlorine. What is the value? Drink desirable standard 0.2. It should not exceed 1. What is the next form? Chloramine. Chloramine means chlorine plus ammonia. What is any ammoniacal substances present in water? They combine with chlorine and form chloramine. It is called combined residual chlorine. This is called radical chlorine. Radical means free. Nobody is controlling it. It has no relation with any other substance. It is in its free form, open, very, very dangerous. That is why the standard is 0.2 ppm. Now, this chloramine is something like it got married to ammonia. Once you got married, you cannot behave the way you like. For example, take this small example. Na plus sodium is positive ion. It is highly poisonous, very dangerous. Chlorine is negative, Cl. Chlorine is negative. It also as an individual is highly poisonous, very dangerous. But what happens if Na and Cl they combine? Both they leave their bad quality and give taste to water. Human life and relationships also should be like that. That is why a wife and husband should be like chloride and sodium. Na plus and Cl minus. Both individually you may be very radical and dangerous and you have your own feelings. But when you combine by those 3 knots, you should leave your emotions, anger, bad qualities in you, and then only your life will be very beautiful. That is what you have to learn from NaCl. Yes or no? So same is the case here. Chlorine has combined with ammonia. Ammonia is very, very dangerous. You cannot even smell it. But when they both combine, their level, intensity decreases. And what happens when chloride is combines with Na in the presence of her husband, or Na in the presence of his wife? Both becomes innocuous. Innocuous means not dangerous, not harmful. Both are good. What is the level for chloride? What is the standard for chloride? 250. What is the basic element in all these things? In all these three things, what is the basic element? It is chlorine. But it is the form which is important. In whose presence you are working, that is important. If the person on your side is ammonia, you are less dangerous. Even though value is 4, that means almost how many times? This is 5 times, that is 4. 20 times its aggressive nature decreases. And when it is in the combination with the sodium, what is its standard? When sodium is there, it does not show its arrogance. It is not aggressive. It becomes very humble. So what is the desirable standard for chloride? What is the desirable standard for chloride? 250 mg per liter. Have you understood now? The form is always important. In which form you are there? That is very, very essential. So you have to understand. Suppose in the examination, I ask you to write the standards, desirable standards for chloride in drinking water. Then for chloride, how much it is? For free residual chlorine, how much it is? If you write this as 500, and if you write this as 1 ppm, I will give you full marks. I'm not interested in whether you should only know that this as an individual in its radical form it is there. So even at a low concentration it is very dangerous. Today in this entire world, maximum number of people are dying because of one single element, and that is chlorine. All municipal water treatment plants, chlorine is used. Chlorine, very, very dangerous. But water chloride, if it is in the form of chloride, it is not dangerous. So I want that you should remember the value based on this. All in the gate examination, etc. Also, whenever in the competitive examination, they will not make you remember the answer as it is. You have to understand this basic philosophy. Now another thing, ammonia. Ammonia as nitrogen, its standard is 0.5. Ammonia is very pungent, very dangerous. It gives a very pungent smell. But nitrogen in the form of nitrate is not that dangerous. Nitrogen in the form of nitrate, what is the standard? 45 mg per liter. This difference you should know. But all these things you have to remember. If you remember like this, then the values, if instead of 45, suppose you have written as 50, or you have written as 25 also, it is okay. It is not a wrong answer. Especially when it comes to gate examination or competitive examination, when you are given 4 values, easily you can pick the correct value. Then total alkalinity 200, 600. Total hardness 200, 600. You should know that alkalinity and hardness both are more or less, they represent the same type of nature. If water has alkalinity, it has turbidity, it has hardness. If it has hardness, it has alkalinity. Turbidity, hardness is caused by which parameters mainly? Carbonates and bicarbonates of calcium and magnesium. And calcium only causes CaCO3, which gives alkalinity to water. So that is why you should remember that if alkalinity is 200, if you remember one point, the other point you should remember. Both are same also. Am I clear? Like that you have to understand. And the calcium and magnesium values are always very, very high. So it will not be in the form of 0.5 or 1. That is wrong. Hardness is caused by calcium and magnesium. Let us say 200 mg per liter is the standards for hardness. Hardness is caused by 2 parameters mainly. What are those 2? One is calcium, The other one is magnesium. Look at me, very important question. Assume that assume that 50% of it is caused by calcium and 50% of it is caused by magnesium. Then what is the value of calcium? Please write. What is calcium hardness? Assume that 50% is caused by calcium, 50% is caused by magnesium. Then what is calcium hardness? 100 mg per liter. 200 mg per liter is the standard, na? Am I clear? Water sample has a hardness of 200 mg per liter as CaCO3. All these are expressed as CaCO3. Why? What is the molecular weight of CaCO3? 100. Ca is 40. C is 12. O is 16. 3 into 16, 48. So total is 100. Because total is 100, very easily you can do it. That is why all these are expressed as CaCO3 only. So what is calcium as CaCO3? 50%. That means 100 mg per liter as CaCO3. Then what are we asking? Calcium as Ca. How much? On a scale of 100 it is 100. On a scale of calcium molecular weight is 40. So what is the standard? It is 40. Am I clear? If calcium as CaCO3 is equal to 100 mg per liter, what is calcium as Ca? 40. Now, the second question. What is magnesium as CaCO3? 100 mg per liter. 100 mg per liter as CaCO3. Magnesium as CaCO3. Now the question is, what is magnesium as Mg? 100 into magnesium, it is 24, 0.24. I know that you are not understanding, but try at home. Do at home. In such a short period, maybe it is difficult. Just try at home. Next time when you do, we will solve one more problem based on this. Then you can understand very easy. But don't lose interest in doing. Am I clear now? So if the question is, if 50% of the hardness of a sample, don't write, just listen. If the hardness of a water sample is 200 mg per liter as CaCO3, 50% is caused by calcium, 50% is caused by magnesium. The question is, what is calcium as Ca? What is magnesium as Mg? The answer is, calcium as CaCO3 is equal to 100 mg per liter. Therefore, calcium as Ca is equal to 100 into 0.4 is equal to 40. Magnesium as CaCO3 is 100 mg per liter. So magnesium as Mg is equal to 100 into 0.24 is equal to 24. Very simple. We'll do it once again in the next class. But what are the standards for Ca? 75. What are the standards for magnesium? Sometimes there is no rule that 50% is caused by calcium. There is no rule like that. Sometimes 90% of the hardness may be caused by calcium, only 10% by magnesium. Sometimes 90% is caused by magnesium and 10% by calcium. But you should see that magnesium concentration should not be more than 30. Calcium should not be more than 75 individually. Those two things you have to remember. That's all. Next please. You have to remember, there is no other go. Aluminium 0.03, copper 0.05, silver 0.1, fluoride 1, zinc 5, iron 0.3, manganese 0.1, mineral oil 0.5, phenols 0.001. All these are toxic substances. What is meant by toxic? Poisonous, dangerous, at low concentrations. Low concentration means if you observe closely, except for zinc, rest all are very, very dangerous. The highest value is 1. Because they are toxic, at very low concentration of less than 1 mg per liter also, they can kill a person, especially infants and children. If they drink water with these things, and sometimes even an instantaneous death may take. Cyanide, cyanide, suppose somebody, here it is not there, cyanide is not there. But suppose cyanide is given in the examination. What will you write? I don't want you to know the exact answer. What will you write? 0.1. Or you write it as 0.3. Anything is okay. Or 0.8, 0.05. Anything is okay. That only we want. We should want you to know that it is a toxic substance. So the desirable standard is less than 1 mg per liter. That is what you should know. That's all. Iron and manganese, they always live together. They're almost like you, the best friends. If roll number 1 does not come, 2 also does not come generally. Both are absent together. The same way. So iron and manganese, iron gives, please note that iron gives red color to water. If iron is there, red color is imparted, given to water. Manganese gives black color to water. Iron in food substance is very essential, especially for girls, especially for women of any age. Pregnant women, for example, they need a lot of iron. That is why they should eat jaggery, bellan jalebi tinala. Jaggery is full of iron. There is a simple phenomena, anything red is blood. Pomegranate, 100% iron. Beetroot, 100% iron. Leafy vegetables, 100% iron. Apple, apple when you bite, what happens? Within a few minutes, you will get a reddish color. That red color is obtained because iron combines with oxygen and form iron oxide, which is red in color. So all fruits which are red in color, they give a lot of blood. So fruits you should eat. Okay. So anything, if water contains iron, it gives red color to water. What happens if color is there? Go to physical parameters. Consumer acceptance decreases. People do not like it. It leads to psychological problems. Can you drink water which is red in color? Even though I say with 10 doctors on my side that this is okay, it is not dangerous, you can drink. Will you drink? Why? It causes, if you have with that in mind, if you drink, it causes a problem also. So iron gives red color, manganese gives black color to water. Then aluminum, 0.03. Aluminum generally in some areas, for example, Srikakulam, now we are having bauxite mine. What is bauxite? It is an ore of aluminum. So in those areas, the groundwater may contain aluminum. Even in East Godavari, some parts here and there, they have high concentrations of aluminum. If aluminum is there, it causes an acute stomach ache. Stomach ache, you know? So sweets, you see most of the sweets, they are covered with a white color sheet, aluminum foil it is. It is actually aluminum. But we're also crazy that if a sweet is covered with a white color foil, we are easily attracted by it. And that leads to a lot of stomach problems. Time is, we'll close here and the last slide. So these are all toxic substances. Cadmium, 0.003. I said 0.5, if you write, I will give you marks. I stand by it. It is true. We don't expect you to remember all these values in a foolish manner. But it should be supported by some logic and some sort of understanding that these are all toxic substances, highly toxic, so their value should be very, very less. Chromium should be 0.05. If you write it as 0.1, it is okay. If you write arsenic as 0.1, it is okay. Nickel 0.2. From where we get this? Solid waste, they contain this. For example, a computer is there, laptop is there, it contains so many different types of chemicals. So when they are dumped into a land, when water falls on that, when there is a rain, it collects all this and gradually the groundwater is percolated by it. And even if it contains 0.001 means, if you throw one laptop for the next 10 years, 20 years, the water will be permanently every year because the rain is gradually contaminated with, it will be supplying nickel over a period of time for several decades. So this is the problem. Next please. So in the next class we will get back to this once again. But this is the biological parameters. The previous one is chemical parameters. The first slide is about physical parameters. This is the only thing, and that is called MPN. MPN means most probable number of coliform bacteria in water. So the only test required is E. coli or thermotolerant coliform bacteria shall not be detectable in any 100 ml sample. That means if you take 100 ml of sample, it should not be found. Uh, it should not be found even in 100 ml. And that is the standard for water intended for. That means for the source, not for drinking water. The first one is not drinking water. It is the source of water. This is for the second one is for treated water, water which we are drinking. In that, the total coliform bacteria shall not be detectable in any 100 ml sample. If you take 100 ml, you should not find one single bacteria also. Whereas in a normal case, if you take 1 ml of water sample, a contaminated water sample, you will find 10 to the power of 5 bacteria. That means 10 to the power of 5 means almost 1 lakh. 1 lakh bacteria you will find. Whereas in treated thing, you should not find even in 100 ml, you should not find even a single also. That means normal case in 100 ml, you will find 10 to the power of 7 bacteria. That means 10 billion bacteria will be there. Whereas in this water, which is the distribution system, this sort of bacteria you should not find even in a single number. That is how the quality of water should be. Guinea worms cause one particular type of disease. They should be absent in a 10 liter of water sample. Organisms like algae, natsu, zooplankton. Plankton means small plants. Phytoplankton. Phyto means light. They must be absent. With this, we will close. And this topic is a very important topic. And if 22,000 children are dying of age less than 5 years, or they are dying every day in the world, the number one problem is we are not able to supply potable water, safe water to them. And this subject, today's class tells you how the quality of water should be with reference to the physical parameters, chemical parameters, and microbiological parameters. We'll brush our skills in this particular subject in the next class. We'll close the program in last 2 minutes. I invite any two students to come very quickly and tell the 1 or 2 points you have learned today, the most important points of learning. Please hurry up. Remember that your friends from so many engineering colleges, majority of them have not participated in the today's class, and I'm not going to repeat what I have told today. You are definitely benefited at a higher level compared with what those friends who have enjoyed the day in a different angle. Please come.